So now we are going to start our session 3, floating solutions. Now I would like to invite on stage our speaker, Mr. Rasim Asgarov, Managing Director, Brigantine Marine Consulting, Vice Chairman of the Joint Branch of RINA and IMarEST Singapore. And his speech is a sustainable, integrated, multi-level floating farm concept, Singapore perspective. Please put your hands together to welcome Mr. Rasim.
Thank you and good afternoon. Today we will talk about floating farms. And this is a job, this project which we developed together with our colleagues from our Society of Floating Solutions, founded by Mr. Lim. So we did it together, and it is a job which is designed to demonstrate feasibility of concept. It's very preliminary job, and please take a note, and then we'll talk about the numbers. So everybody knows that Singapore faced a shortage of food, not a real shortage, but risk of shortage during the COVID. Generally, this is a problem of entire world. Population is growing and food is in demand. So government take a note from this situation with the COVID, and there was a program accepted that by 2030, Singapore is supposed to provide 30% of food locally. And we believe that our floating idea to provide the food is one of the ways to develop this in the future. So there is a lot of legislation with regards to the shipped and shipping fishery and some kind of ecosystem in the sea, but very few about agriculture, floating agriculture. We consider the floating solution because Singapore has a lot of water area. Lot, it's a relative term. Of course, it's not so much as other countries have. But you may consider the exclusive economic zone of Singapore, it's a zone when Singapore can really, nearly everything which they want to do, is 714 square kilometers. It cannot be used fully because there are a lot of restrictions. First of all, navigational, security, and political reason, which is restricts the usage of some area of this territory. But we still have a plenty of areas where the floating stuff can be allocated. But we need to keep in mind that it's not sizeless. It still have a limit of the size. So the same as Singapore has a limited land, Singapore has a limited water. And for this, our idea of multi-level floating farm is a good solution. On this picture here, you can see an area which is already allocated as suitable for farming, floating farms. And some of the floating farms, first of all, floating fish farms, is already there installed. But it's not only area which could be used. In terms of hydrography, Singapore provides very good condition for such development. First of all, sheltered water of Singapore have a very low wave on this area. For example, 10-year return period significant wave height is only 1 meter. It's very low. If you consider seasonal maximum significant wave height, it's about 0.3, 0.35 meter. And in between monsoon period, it can go down for 0.1 meter. We believe that it's insignificant and will not affect our project much. On the other hand, wind is a different story. Average wind in Singapore is quite low, but during the northeast monsoon, wind can go up to 20 to 25 meters, sometimes even higher. Therefore, it should be taken in account because windage of our project is quite big. Current here, normal current, tidal current is about 0.5 to 1 meter per second. But between the islands and some narrow streams, it can go up to 2 meters per second. Wind generated no tidal current is quite low, 0.4 meters per second. But generally, the speed of 2 meters, it's a significant speed and have to be taken in account when the mooring load calculation. When we talk about tides, tides is quite significant in Singapore. It could go for 2 to 3 meters high. But the nature of our project, the decision which we use in the mooring, make it indifferent to tidal variation, and we will talk about this later. What about the water depth? We talk about this area, this is dedicated for farming today. But on this map, you can see that from 0 to 40 meters, it's a blue and green zone. It's zone which could be used for floating farming. So it's bigger than it's already dedicated. Not all of this area can be used, we already talks about it. A lot of the area is dedicated for navigational purpose, security or political reason can be used. But still there are plenty of places. This is how our project looks like. We have a 6-store floating farm. Bottom line, it's not visible here. It's a double bottom and fish farm. First level, it's a loading bay. Second level, it's a kitchen and egg production. Then 2 levels of hydroponics, indoor hydroponics. And top level is a greenhouse. Greenhouse because we have a transparent roof, partially used by solar panels. Access to this farm could be 2 ways. One of them is a floating road. If it's close to the shore, then using the floating road, we can transport goods with a normal lorries. If it's far from the shore, then it will be used by boat and by ships, all logistics. Conceptually, if all project was divided by 2 parts, a floater, which is includes structure and all machinery, shipping machinery, and 4 farms, which include all farming equipment and everything for production of food. This house looks like in this section. You can see that in the middle we have a column. It's a core area which is separated from the production. It's sometimes even airtightly separated from production area because of some reason. We will talk about it later. And this is for human location, for laboratory, for personal staff, for workshops. Its overall size of this platform is 60 by 60 meters, which gives us 3,600 square meters total area. And inner part, which is a core area, is about 400 square meters. The rest of each level is 3,200 square meters. It's a production area, which is dedicated for production only. Here we can see numbers of its overall hydrostatics. What can be mentioned here? Draft is 7 meters. Depth is the elevation of the main deck is 9 meters. So we have a 2 meters freeboard. For Singapore water, we believe it's good enough. Total displacement is 25,800 tons. And what I want to mention, it's a stability. It's a metacentric height of 26 meters. It's a huge. Normally, rules require 0.2 meters to be safe. I would like to keep it in mind because we will talk about it later. So this is a total estimation of the cost of plotter. Of course, it's estimation. It's not based on the project drawings. It's based on the analogy, on the prototype. But it gives us some idea about how much it can cost. We believe it's cost about 30 million plus. Core area. We discussed about core area, and every level is 6 meters high. So far, we have decided to divide it by core area by 2 levels, 3 meters high each. Lower core is mostly for anything which is related to production. It could be laboratory, processing room, control room, anything which is need to be on the level of production. Upper core is actually optional. It's more for comfort of the crew. If this platform, if this farm is located near the shore, the crew can be delivered every morning and every evening and go home on the lorry. If it stay a bit far, then we need to have a crew to stay on board on the watch. And for that, we have an upper core with the cabins and everything for crew living on board. Ground level, it's double bottom with the tanks. It's not actual tank, it's just indication of intention, nothing else. But you can see that it's a fuel there, sewage water there, fresh water, rainwater, and ballast tanks. Ballast tanks, we need to keep the draft level on the same level with a change of loading. Total volume of it, estimated volume is 10,800 cubic meters. Ground level, level 0, it's partially underwater and it's fully below main deck. It's a fish farm. It consists of the 6 round tanks, total volume of 6,000 cubic meters. It consists of auxiliary equipment for fish farming, which is hatchery, nursery, recirculation system, feeding and control system, pumps, etc. And also it includes some part of ship machinery. First of all, it's engine room, pump room, and control room, switchboard room, something which is noisy. We keep it underwater. We don't go deep into the numbers, so just for information. This is isometric view, and this is typical picture of the similar fish farms. What I would like to say here, we evaluate every production from break-even price. And we believe that our price is sufficient and suitable if it's 25% lower than wholesale price or 40 to 50% lower than retail price. Sometimes we don't have a wholesale price for some products, so we use retail price. And that's where we compare it. Next level is the loading bay for lorry to pack it for general storage. Then we have another part of the machinery, ship floater machinery. And the rest of the room is occupied by mushroom farm. Mushroom farm is a less demanded and cheapest farm. They don't need water, they don't need light, they don't need air, little bit. So it can be placed anywhere, but it's very important part of integrated farm. We will talk about it. This is typical farm. Just somewhere. Level 2 is an egg and poultry farm. It's a caging along the wall, which is a chicken stay. As a prototype for this project, we selected a high-tech farm, very expensive one, with a automatization of the egg production cycle, including battery egg line, temperature control, scientific feeding and mechanized eggs collection methods. This was done for conservative approaching in our estimation. Level 3 is a leafy green. We select the lettuce production for this level. It is rows of the shelves with the greens on top. We select 4 tires per rack, which is 1 meter high, especially to get it more open for sun to come in. This is also quite high-tech system we selected to be conservative in our estimation. This house looks normal, quite dense tire, which is small distance between it, but it's require a lot of energy for lightning, artificial lighting. Level 4 also indoor hydroponics, but different kind. It is high wire vine crop. We select tomato. The difference is that it grows on the vertical wires. And we have used 2 tires for it, each one 3 meters high. It is also hydroponics because it's indoor hydroponics, it's closed. Level 5 is the same tomato wire system, but it's already greenhouse. It has a transparent roof. So its difference is with really reduced power demand because it's much more light there, and we reduce the cost of electricity. Everything else we keep the same as for level 4. Now it's another sample of higher wire green arrangement. Mooring. We need to say a few words about mooring system. We consider different type of mooring system, but we believe that best is a piling. Piling is cheapest and easy installed among all, easy connected and disconnected, easy remove and transport the system to another place. It's the least harmful for environment, and it can be done independent or indifferent to the tide and level changes using this kind of rollers. This is quite standard equipment. So in our case, mooring system limited horizontal transferring. It doesn't limit vertical mooring. So we can ballast, deballast, we can allow him to change with the tide. That's quite useful in this case. This is estimation cost of total floating farm, including the floater, all farms separately. So total estimations for 57.7 million. It's quite a lot of money, but we would like to demonstrate that it's worth to invest. So what is the benefits of our project? First of all, you need to understand that we select 6 level, it's just example. We talk about stability. We have plenty of margin of stability. We can build 10 store, 15 store. Of course, it needs to be checked. But preliminary, we can build much more levels. And the most expensive part of this project is a floater. Floater and its bottom part is machining. Building each level on top of it, it's quite cheap relatively to this. We just need to increase the size of farm, the size of capacity equipment a little bit to compensate one more level. But one more level add a lot of profit from the production. If you compare the things, you see that each level added to this platform reduce the cost and price of final production. You can see it on this table. With every added level, break-even price is go down. It's not from our project, it's from another project, but it's still valid. Another thing is another benefits of our project, it's energy conservation. Total demand is 22 million kilowatt per year, quite a lot. The solar energy from solar panels, we can collect about 570,000 kilowatt, which is about 3 to 5%. It is saving, not much, but saving. We have another way of source of saving of energy. It's the solar. If you can see here, this is a diagram of solar movement. This is a day movement. And this is a year movement. So if you place our platform as rectangular, square, 45 degrees to the north, east, then we have sun every day illuminate minimum two sides. And if we consider daily elevation of the sun, we can see that from 3 to 6, 7 o'clock, sun go from close vicinity window, go deep inside into the window. So what we need to place a sensor on every shell of hydroponics, which switch on the lights, artificial lights, when sunlights will go too dark. So when sunlights come in, it's switch on. It's saving. By our estimation, we can save about 50 to 20%. Water conservation, we have also a way to conserve. First, we need 40 to 50,000 cubic meters if we consider seawater, fish farming. And we need about 600,000 meters if we consider freshwater fish farming. But don't be scared of these numbers. We have a lot of way to save. First of all, it's condensing water from air con. Just to condensing from 33 degrees to 23 degrees, comfortable temperature, we can get about 8,000 cubic meters per year. It is just a normal condensing, but we have a lot of evaporation from the green, which is added to this. It depends on the green, it depends on the season. So it's really difficult to evaluate, but it's quite a lot, maybe double this number. This all water come back to the system and can be used again and again. Another way is the harvesting of rainwater. We can harvest about 8 to 9,000 cubic meters of rainwater in Singapore using the size of our roof. This also can give a lot of saving. If we exclude the fish farming, we can get about 20% of the demand of the rest of the farm. With fish farming, of course, is much less. Yes. Another way which is, we believe, benefits of our project is integration. What does it mean? The farms which we use is not a standalone farm. They're working together. First of all, and most important, it's a integrated waste management. For example, poultry farm produce a lot of manure, but manure used for feed fishing farm for centuries in Asia. It's very old, famous and well-known technology. So with a little bit of processing, this manure can be used to supplement fish feeding. We need for that create special ecosystem with some special fishes, some seaweeds, crabs, and shrimps, but it can give us quite a lot of advantage. You can see here. Sorry. Yes. You can see here in the table, it's a coefficient of production, which is increased when you use this multicultural ecosystem, up to 4 times. Fish farm produce a lot of contaminated water. The water needs to be renewed at least 2 times in a day, and it's really contaminated. But this water is a good nutrition source. Good nutrition source for the hydroponics. And on the other hand, if we use a saltwater fish, it could be processed through the freshwater generator to produce a lot of fresh water from used water. So we don't only clean the disposed water, we also produce a lot of water. Agriculture produce a lot of, hydroponics produce a lot of green with great enthusiasm. Also, this waste could be used as a mushroom production media. Mushroom itself is a very good product that's decomposer of all waste could be used. But mushroom also could be used as a feeding for mushroom farms, spent mushrooms, can be used as fertilizer, can be used as a growing media for hydroponics. It can be used as a growing media for insects, or worms, to feed the farm and products. We don't have much. So we check this efficiency. We check this efficiency of the products based on the two modes of operation. Build to order, it's when owner build it for the owners and produce their own food. This have a lot of benefits and disadvantages. Mostly the owner plan and produce which foods we grow, how to integrate it. All the management and marketing is shared. So it's a lot of saving on it. It's the most efficient way. It's highly risky because it's more expensive, but gives a more profit. Here you can see it's EBITDA and it's, no, it's not cheap. So EBITDA is quite high. Another mode of duration is a build to rent. When it's speculation build, owner is building, it's without any farming equipment and rent it out for tenants. Tenant build own equipment, build own farm on their own cost, grow the products and sell it himself. Owner get only rent from him, rent per meter, rent for electricity per kilowatt, rent for water per cubic meter, rent for ventilation, fixed rent. This way, integration depends on the goodwill of the all peoples. Still be possible, and in this case, if in the first case all this waste will be distributed and processed free of charge, in this case it should be done for money. So all farms need to have agreement about selling and buying all this waste to be used. This way is less risky for owner, but gives him less income. EBITDA here is a formula, nearly 2 times, but it's still quite a lot of money, still effective. So on conclusion, we can say that floating farm is a very good prominent way for domestic food security. This requires higher initial investment, but provides additional economic benefits. Besides this sustainable food production, we can get a reducing on the logistic expense, shortening of delivery of fresh food to the actual total consumption, and localized control of quality as a value-added process. Increasing of number of floor will increase yield per meter square, overall productivity, and reduce the cost of production of each kilogram of product. Smart use of sunlight, solar energy, rainwaters, condensed waters could improve the efficiency, as well as effective integration of farm by reusing the recycling of waste. Thank you. That's complete now. If you would like to know more about it, it's published on the ResearchGate. You can Google the name and get a full article with all details. Thank you.
Thank you so much, Mr. Rasim, for sharing his floating farm concept from the Singapore perspective. So for a gentle reminder, if you would like to ask questions, please scan the QR code on your table, and the question will be discussed during the panel discussion. So now I would like to invite the next speaker, Dr. Paul Ong, and he is the senior lecturer from National University of Singapore. His topic is floating farms. Please welcome.
Thank you. That was a very interesting talk on floating farm. My presentation is a lot simpler, much smaller scale. It's a bit of blue sky thinking, of course, because a lot of these ideas about floating farms or this, Singapore hasn't really built one in terms of floating farm except for floating fish farms. So floating farms. Just to introduce, this work was kind of joint collaboration between NUS and TechSpace. It's a Dutch company, so I've collaborated with them on this project, and I've got the students to design this. It's a very much smaller farm compared to what we've seen before. Okay. Okay. So quick introduction, right? Simple food story. I think you've heard about it. I don't have to explain much. We need a food supply. And let me do a simple introduction on FlexSpace. Right, FlexSpace is a Dutch company who's 8 years experience in building floating systems, mainly for buildings, not exactly ship type, but flat buildings made of concrete. So if you look at FlexSpace, if you look at design, all of you are naval architects, marine engineers, right? You design a pontoon. What you're trying to do, buoyancy force, is displace water with a volume void of air, right? Create a buoyancy force. What if that volume of air is this compromised, a leak, right? You have ingress water. So naval architect says we're bulkhead, we're compartments, right? So that at least one compartment is flooded, the rest compartments are not, you're safe. Right, so FlexSpace, what they're doing is taking the void, instead of having air as the void, fill it with expanded polystyrene. So what is shown here, actually at the bottom layer, is expanded polystyrene, styrofoam, right? Using styrofoam as the void rather than just air, right? If you do a standard pontoon design, you do a box shape, you build bulb walls, you all add weight, dead weight to it. Inside is just pure air. Whereas EPS system here, FlexSpace, we use expanded polystyrene to create a void purely for buoyancy force only. So the expanded polystyrene has no strength. Obviously, you can bend it and break it. So that's no strength. The strength comes from the concrete floor that goes on top. So to build a concrete floor on top of it, the styrofoam is purely for buoyancy. If you look at the concrete floor, then it's designed like a normal floor with beams, drop beams for the bending, and the floors for punching, shear, design, everything. You design like a normal floor. There are three types. There was FlexSpace Light, which is mainly for simple light use, like recreation use, football field. Then you have standard, you can put up maybe a 3-story or steel structure. And then the heavy, you can put more stories, even a car park on top of it. Right? So we're looking at FlexSpace standard here, which is using a standard to build a 3-story sort of steel auto frame design. Right, so these are FlexSpace projects that have been used in Holland. One is the top one is a greenhouse. You can see it's using the standard design for a low-rise steel structure. The office again is a very low-rise steel structure. What you have is a concrete pontoon. Well, inside the concrete pontoon is styrofoam providing the buoyancy force. The bigger structure they've designed is floating pavilion, which is actually built there. Of course, the lightweight one is the floating bird island. It's a very lightweight structure that's built there for natural use. So let me go and see this farm that we have. It's actually a very simple farm that is built in compartment. Of course, you can expand this, but it looks like a barge, of course, from the far, made of concrete as a base, and then a portal frame on top of it. So it's actually a very simple design. We don't have multi-story structure in there. Hopefully the video plays. Video plays? Yep. A short video that's actually created by my student to show you how the farm looks like. So you can see it's auto frame on top of a concrete building, a concrete base. We're using FlexSpace solution. Then it's a very simple concrete steel structure. A very simple portal frame steel structure on top of it. 3-story high, suitable for the flat space standard products. I think if you're a neighbor architect, you say this is easy to design, right? There's nothing complicated about this. Even the student can design this. So nothing difficult. But I'll cover later on some of the challenges we face, non-technical challenges. The mooring systems are very standard catenary moorings. So since you've seen the video, again, very simple structure, steel portal frame. The reinforced concrete slab is made of concrete, and then the flex space pontoon is actually where the EPS is, the expanded polystyrene. Of course, we use the standard one, which allows to build a 3-story building. And then the concrete slab and the transverse beam longitudinal beams are just standard reinforced concrete that you design for buildings. I'll just go very quickly. This is how it looked like eventually. Design summary, I guess floating bidding is a bit new in Singapore, right? We really haven't designed a real floating bidding. We have the floats, marina float in there, but we don't have a building that's designed to house people and offices. So when it comes to codes, right, if it's a civil engineer, we follow all the standard Euro codes, right, with the annex, Singapore annex to it. And we design according to that for the actions and the resistance for the concrete design. But as a marine engineer, you know that the Euro code doesn't cover like station keeping, stability, watertight integrity. So we have to use other codes, EMB codes, API codes to substitute to do the subsea design. Right, this is just the steel portal frame, and that's the concrete slab there. And then you can use any civil engineer would be able to design this using a structural engineer designer, simple slab design. So the construction of it, as I said before, you're using styrofoam purely for the buoyancy force. So the styrofoam are glued together first to create that base for you to cast concrete. And I'll show you some pictures of the construction. So this is the actual construction of the Rotterdam floating pavilion. You can see the styrofoam is used as a buoyancy base so that you can cast concrete on top. All right, and in the styrofoam, you actually lines there for your longitudinal and transverse beams. So once you form the base, then you actually cast the concrete on top of it. So you can see the concrete is being cast there. On the bottom, with the white surface, that is the styrofoam. Right, you cast the concrete for the beams. And then once the beams are cast, you cast the entire slabs on top of it. The good thing about this is you don't need dry dock. You can build this on a Galam basin, and a reservoir, in situ, a small structure, right? You don't need to pull it out, right? Build it somewhere in a dry dock and pull it in. Right? So you just build it on site. So those are technical challenges, which I think is very easy to solve for a naval architect. Let's look at the non-technical challenges in the Singapore context. Right, so currently, if you design any floating building in Singapore, there is no guidelines and legislations for any floating structures, whether farm or buildings. There's no real guidelines. So if you look at coastal development in the sense of not a ship, right, for buildings or farms and anything, or even hotel, there's two locations. Either you do very coastal inland, you build a gangway bridge, stretching out, you can have road access, everything. You connect your water, electricity to that. It could be a ferry terminal, for example, or you do something quite offshore, further out, right? Because you need the water depth. You have a certain draft, you need a water depth, you need to build this further out. Then the gangway bridge doesn't make sense. You have to transport everything by ship. Hopefully you lay a subsea cable, otherwise you generate own electricity And Singapore is all still diesel generators, right? Even our islands, Pulau Sebaru, for example, is still burning diesel to generate electricity, although Pulau Sebaru is so near to Singapore, right? We don't have a subsea cable to connect it. So if you are an engineering company trying to sell solutions, a fluent solutions company to a developer that says, wait a minute, if I do it offshore, I have to generate my own electricity, to steal my own water, the whole lot, right? It's basically like a ship. So my cost is going to go up. If I do it close to shore, which is much better, then you know in a close to shore, you don't have to water depth, then your draft is limited, right? And if our tidal difference is plus minus 2 meters, which means a low tide, there's a risk that your structure may get stuck in the mud, right? So you need a substantial sharpening depth for the draft. So you have this dilemma. And so, but the issue now is, the answer to the question is, when you decide this, let's say you decide to go a bit further out, to get the water depth, then this floating structure in the Singapore context, is it a landed development, a coastal extension of landed development, or is it considered a non-self-propelled unit, a barge? Right? Is this a floating barge made of steel or concrete, whichever you like, or is it an extension of a landed development? Right? There are gaps between the Singapore regulations and classification rules, right? So if you consider this as a barge, you're more or less considered as a classification rules as a non-self-propelled unit. If you consider as landed development, then you're under the BCA rules of landed development. It's just an extension like coastal building, right? At the moment, who is the governing authority for floating structures? Actually, it falls to two parties, actually. Let me go through this, right? So if you go to any planning development in Singapore, the first part, planning development, is you have to go to URA, Singapore Land Authority, MPA, and NEA, right, for floating structures. Right, so URA is basically looking at the master plan, whether it meet the close fault ratio. Singapore Land Authority, assuming you're taking some of the coastal land. MPA, which see whether you're interfering with the sea routes. And NEA, who's making sure you don't have any discharges that is damaging the environment. Once you've done that, the real building control authority is just BCA, the only building control authority. Whether you consider a floating structure or building control, BCA is the only authority that needs to approve for that building structure. The rest, fire safety, you got the Singapore Civil Defense, utilities, PUB, and then NEA again for the EIA, the full EIA. Right, so if let's look at building control, right? We look at Building Control Acts, Section 2. This is the actual legislation from BCA. There is a definition for floating structure. It's defined as not being a boat or vessel constructed or to be constructed a floating system that is supported by water, not intended for use in navigation, and is permanently moored. Right? If you satisfy these three criteria, your floating structure is considered as a building structure. Like any landed development, right, is considered as a building structure. This additional clause was added in about 2007 or 6 when they built the Marina float, because it was the first ever floating structure that they built. BCA has no way to govern that, right? What do you call that? What's the Marina float like, right? So they added this definition in there to satisfy the requirement of the Marina float, right? It's called a floating structure because the Marina float is permanently moored, is not used for navigation and supported by water. And therefore, it's considered a floating structure. Sounds great. If you take this and you apply to all the fish belongs in Straits of Johor, or the fish farm that was built using wood and plastic canisters, then all the fish farm, in theory, by law, are considered building structure, which means BCA needs to approve every fish farm on the Straits of Johor, right? But if BCA were to go and inspect all this fish farm, they will all fail an inspection because all this fish farm that was built using wood and plastic canisters were not designed to Euro code. There's no quality control. The fire safety hazard, they will all fail the BCA regulations, right? So I raised this BCA before. I says, all right, sorry, there's one more point. The fourth bullet point, which never written in law. You will only consider a floating structure as a building structure if and only if there's a gangway bridge connected to land, either a bridge or the jetty. If it's connected to land, we consider it as a building structure, like a ferry terminal, right? That's a floating structure. it's considered a building structure. But if your floating structure is out to sea, there's no permanent connection to land, sorry, not our jurisdiction. It's either MPA, who's governing ship, Singapore Food Agency, who governs the floating farm, right? So the floating farm that we have, except for EcoArc, all the floating farms that we have in Singapore are not governed by BCA. They're not governed by MPA. They're governed by Singapore Food Agency. The Singapore Food Agency only interested in food production. They're not structural engineers. They're not neighbor architects. So they have no idea whether the structural integrity of that structure meets any Euro code, right? It's not a concern, right? They are not structural engineers. So that's the biggest flaw in a sense in our law, because this gap has never been filled, right? So if you ever think of trying to build a floating structure in Singapore, you have this problem because by law, it doesn't really define whether your structure is a building structure or a floating vessel. So if you're building structure, then if let's say you're building a floating ferry terminal connected to London, they'll say, follow our BCS building safety. These are the codes that you need to comply, right? Again, by law, BCA do not recognize any DMV, APS, NORSOC, whatever code they use for marine structures, BCA do not recognize them, right? Officially, they do not recognize. They only recognize the Euro codes, the standard Euro codes for design. Of course, you have the problem URA, which has this gross plot ratio, which you have to comply based on the master plan, right? Again, floating structures, there is no similar quantum use for floating structures in Singapore because floating structures are not considered as land development. If you talk to URA, they will tell you the Marina float that was built in 2007 was considered as a temporary structure until today, right? Because when they built the Marina float, it was meant to be a temporary structure for the national parade because the national stadium was under renovation, was basically under demolition. They're building a new indoor stadium. So they built the Marina float as a temporary structure. And ever since 2007 until now, URA has always considered as a temporary structure because it doesn't satisfy the quantum use of land. But the Marina float is not an efficient use of land, it's just a piece of flat surface, right? So, and now they're going to demolish it, they're going to build a permanent structure there now, right? So the Marina float is going to be disappearing, right? Okay, the biggest problem, I think, for all engineers, if you advise a client, next thing is OPEX, right? Back to the question, is it a building structure, a marine vessel? Right? If you consider it as a building structure, then the Building Control Act in Singapore governs all inspection buildings. And actually, it's quite relaxed because imagine if there's a non-residential buildings, a farm, a ferry terminal, then inspection is only the first 5 years and thereafter 5 years. Every 5 years you inspect it. The inspection is only visual inspection, any loading or alteration of building, nothing else. Simple, right? If a residential building decided to build a floating house, then the inspection is first 10 years, then after no less than 10 years. Very simple. Make your life very easy. Now, the issue is whether I can build a house using a concrete or steel pontoon, a big difference in terms of corrosion. But if your vessel floating structure is further out to sea when BCA says, hey, it's nothing to do with us, it's MPA problem or Singapore Food Agency, then you fall into this classification rules of ships. I'm using DMV as an example here. If you consider floating structures as a vessel, like a pontoon, a barge, then the survey are more stringent, right? It's every year, annual survey, 2.5 years, 5 years, and eventually a bottom survey, right? So huge difference in terms of OPEX. So it's a big, one of the biggest problem if you want to develop a floating structure in Singapore is nobody can actually lay in a hand and says this is going to be insured as a building. You follow the Building Control Act, or this structure is going to be insured as a vessel, and please follow the DMV rules of ship inspection every year, 2.5 years, and 5 years. Right? Especially if you design your pontoon as steel, then I would say you should at least follow this and not inspect only in 5 years. Right? You know, steel corrodes, steel corrosion is inevitable. I think that's about it. So thank you very much. So these are challenges. I do not have the answer for it. Hopefully we'll open up some thoughts and discussion. I think marine engineers, we can design a lot of things on technical solutions. It's all very easy, right? But when it comes to approaching authorities, getting approved, getting insured, then it's quite blur, all right? It's a very gray area in terms of floating structures, in terms of not building a ship, we're building a house, a farm, agriculture farm, right? It becomes very gray at the moment. Right, thank you very much. Thank you.
Thank you very much for Dr. Paul Ong for sharing such a wonderful session about the building safety, the regulations and rules, and the different authority regarding for the floating farms from Singapore perspective. So now I would like to invite the next speaker, Mr. Luigi Checonelo, founder of Links and Synergies Private Limited, and he's going to give a speech about the HBS deck concept, dwellings for the near future. Please welcome Mr. Luigi.
Good afternoon, ladies and gentlemen. Thanks for having me in the first place. Quite an experiment for me, as I'm an absolute beginner in this. I am pretty sure probably you'll enjoy my accent throughout this presentation, my heavy accent. Luigi Marco Checonelo, that was a name, good attempt, by the way. Not even Italians can manage to say that, so you are excused, absolutely. So I would like to start my presentation talking about some wording, which is a key wording for us. We are talking about this the whole day. Change and challenge. One word contains the other, isn't it? And that's true for their meanings too. So in nature, change is a challenge. And in fact, it is only when we are challenged that we truly change. I guess many of you know this picture. 9/11, 2001 was it? 20 years already. At that time, I was barely 2 years into my professional airline flying, and I have really been locked up into the cockpit for the rest of it. So I don't even remember how it feels taking passengers from A to B without having a reinforced bullet doors behind it. It was quite a challenge for me. I spent my careers without this bulletproof door, as I said. I am pretty sure that 20 years later, when 20 years and 15,000 hours actually later, flying hours, I remember getting increasingly uneasy to walk around the crowded airport terminals. I remember literally holding my breath and dodging passengers left and right to go back to the same door, the very same door, very much hated door that was in my cockpit to protect me from the passengers. So that was the beginning of another challenge. I'm pretty sure you are very familiar with that feeling of being uneasy, holding your breath and going around a crowded place. So I'm borrowing now another word, adding it to the equation, change, challenge. This word is opportunity. The greatest challenge to the interconnected world, a clear and present danger that disrupted our lives and scrapped all our rights to interact physically with each other, presented us, however, with the opportunities of making different and more resilient ways of communicating and interacting. Being able eventually, and unfortunately, I would say, to live and connect remotely is, in my view, the greatest present we got from the pandemic, living remotely. So challenges, change, and opportunity. I guess these are the very reasons for human development. Climate change, way more subtle, because the evidence of its reasons is still either in doubt or was even denied by the many people and many people agendas are involved into that. Hence, this is a way bigger challenge because it is not all of us that feels this is too clear and present danger. So it is up to us to connect, brainstorm, synergize, and combine ideas into new solutions. I am in my 50s. My wife is in her 40s, and my daughter is 7 years old. And we all play Lego at home. So today, ladies and gentlemen, I have the pleasure and the opportunity to introduce you to a very special box of building blocks. If it's coming out, it's coming, yeah. This is called the deck concept. Is a multi-purpose and modular service platform by the HBS company, an Italian vessel designer and manufacturer that was born during the pandemic to embrace the challenge and create an opportunity. And by the way, this thing floats, not in all these pieces, but in one piece, of course. Global warming, extreme weather, and rising sea levels are all part of the same problem. And it would be a waste for me today to reiterate the obvious with more alarming statistics. So I choose to add more words instead. Sustainable, versatile, resilient, and easily movable. These are all words that relate to change. And coincidentally, the same words are describing the deck concept, which is a solution to reevaluate the water as a dwelling element. These are the images that you can see for the modularity, by the way. The slides are slipping away, but you will understand probably when I say the rest. So said the Italians during the Italian brainstorming, which I've been lucky enough to participate to. What if we manage to create a structure, a habitable structure, which is effectively able to cope with change of purpose, change of shape, dimensions, along with easy assembly and dismantling procedure, and of course, fast development at minimal cost to the environment. It is a fact that we essentially have not changed the way we build our living and working infrastructures for hundreds of years. And that is because we have not been challenged enough to do so until recent years. There are, however, several well-consolidated habits around the westernized world, especially, and slowly but surely, the building process is shifting towards sustainability of materials and solutions to produce, retain, and save energy more efficiently. So we must push the right technologies today and connect the ideas around these technologies to produce buildings that are resilient to change. Some details about the deck concept, the dimensions. The basic models is the DC3, deck concept 3, is 10 meters in length by 4 meters in width, 3.6 meters to be precise, structure. For those of you who like to reason in feet, we are talking about 30 feet by 12. Floor to ceiling is about 2.2 meters. Board that is below the length of 10 meters. And in fact, the deck concept, as you can see, is 9 meters and 99 centimeters. So that makes this virtually no taxable. And guess what? In two wonderful locations, the HBS company, in creating the two, at the moment, hotel and floated villages north of Italy, the very few, actually the only one at the moment they are coming up with. So imagine these hotel rooms that are in permanent berthing infrastructure, which can be moved, right? Can be moved away. So I find it very cool. The DC3 is the smallest option offered for this living solution. As you can see, 10 meters by 4. These are more images about it. And it comprises of a living dining area, in a second room, which I call it a second room. It could be a studio, could be a bedroom. And then there is an access with stairs to the rooftop. So the rooftop is mainly a terrace that you can, and is the same surface, exactly the same area that you have at the bottom. The maximum length of the deck concept, being a modular structure, of course, is 24 meters, 80 feet. This is a limitation that is not dictated by design, but by the maritime law in Italy, since beyond this measure, the safety on board, of course, including the presence of a captain. That would make the project, of course, not feasible. Let's talk about the materials. 5083 aluminum alloy, main materials together. Let me give you a slide. It is of a few days ago, the news from Matteo Costa, the designer, that he has managed to reduce the weight of this model by about 1 ton by redesigning the floaters. So they're using, instead of aluminum from the bottom, they're going to use some sustainable plastic, compressed plastic, that is, by the way, resilient to the water element. And the design has also managed to improve the amount of passengers that can be carried on board. So we went from 10 passengers to 22 passengers. Modular design is perhaps the quality that has convinced me the most of the deck concept potentials. Imagine an infrastructure that can easily shrink or expand by adding or removing modules longitudinally, laterally, and vertically, which does minimize the necessity of scrapping and rebuilding completely a structure. So you can virtually reuse it, modify it the way you like. See at the bottom, the floaters, they're all divided and they're all singularly sealed, which increase safety of the overall structure because the damage in a single floater will not impair the overalls. Anything from a price. So the designer is happens to be actually a professor at the Politecnico di Milano University, Masters of Yacht Design, and he has pulled up a Concept 3H hotel, where 2 stairs, 2 toilets to access to the common, is making it perfectly. Let me show you that. These are still slides regarding the hotel. It fits perfectly into a 40-foot high cube container. So if you are in a rush to have your structure built, you can actually have this shipped into 2 such containers. 2 40-foot containers will keep my own boats that are coming into Southeast Asia. And as far as they are loaded, the respective markets, Singapore, Malaysia, and Indonesia, as we are speaking actually, loading, assembling, and launching the vessel. Something more about the logistics. While the initial shipment has been organized with already built modules to better control the quality of the finally assembled boat at an IKEA-style shipment, where you mainly take the boats apart literally because it's very, very easy to be assembled, and you will then cut down, in this case, the logistics. Keep in mind that we believe the object will be a game changer and a sound example for the urgent objectives that the Italian swearing if required in the process. Let me talk about energy requirements. These are more pictures about the way my modules. Conventionally, they are catered in the future, however, in the enhanced version that is nearing completion, there is a shifting towards the employment of low voltage current, which will in turn, of course, make it easy to shift towards solar power energy. I am personally pushing for a collaboration with a Spanish company that actually produces semi-transistors to make this structure electrically self-sufficient, while preserving the lovely views by that to control and control better the climate within the module. At Blackwaters, they are connected into 2 1,000 liters tanks. These tanks, they can be, of course, emptied in any marina using the services of the marinas if you're placing it there. But in the future, the idea is to add, since it's a modular structure, a module which is treating the liquid waste and taking them into completely biodegradable water that can be then offloaded in the sea. No toll for the environment. As far as the cost, I might say very affordable at this stage for the market, as the market talks about let's say, the average cost of these kind of products in the market. The idea, however, is for my company, from the HBS company, the production company, is to have it produced locally in Southeast Asia, if possible, so that we could cut down the cost and at the same time reduce the toll on climate and on logistics to have it present right where it is. That would be definitely easy for us. Some more pictures about the interiors. Those are all renderings. The first boat is floating in Italy, and as I said, the other boats will be coming soon and will be visible on this side of the world. All the above characteristics translates into a system that, irrespective of its final use, does protect the initial investment and allows the versatility and resilience to change. That, in my opinion, is a must for any kind of structure on water or not. After the details of the present, what is happening right now, let's have a look at the possibilities in the future. What you're seeing now in the slides is the location of Nusantara, East Kalimantan in Borneo. Nusantara is the name of the Indonesian's newly designed capital, which will be built around and within a mangrove forest surrounded by water canals. That is the pictorial representation of what is going to be. In this context, I envision the deck concept to become the central element of a versatile infrastructure of passenger station, conveniently berthed on the water, or a Venice-like transportation system. Imagine that. What would you say if this system, this structure, is actually morphing by changing its station's location to follow the flow of passengers as it shapes through the year? So statistics on the commuters flow will drive the versatility of the network, which will then mold around the city commuters' needs. No land reclamation, easy scalability or downsizing of the station network, and no infrastructure required, apart, of course, from berthing, water, and electricity. Resilient to sea level, for sure. Easily upgradable and transferable, partially or entirely, into any other location due to the fact that that is modular, in fact. Another example could be to employ this type of structure for a fishing industry to reduce their catch wastage by storing that in intermediate stations, or even any other industry for that matter. We were talking about it with farms and everything, so we could use this as an option to add to farms to give the logistics related to that, for the people to live around that, for example. Floating hotel and villages, that's the last point I'm going to talk about. Imagine a worldwide connected network where the guest will find the same level of comfort and familiar atmosphere, but in many different places. By the way, these are just some of my sketches that defines the mooring. By the way, I was saying the first and very exclusive floating hotel in Southeast Asia will be ready to host you right across the channel, right here in Nongsa Point Marina, Batam. It is so exclusive, in fact, that is not real yet, because it will be done by the boats that are coming in, but it will be there soon. And that will give you the possibility to experience physically how it is to be on board a deck concept. So this will function as a probe to advertise this kind of solution in Southeast Asia. While in Northern Europe, this is quite a consolidated reality, floating reality, as we were saying, perhaps leaving fewer opportunities for us. I think in Southeast Asia, we have to work harder at connecting the suitable stakeholders to funnel energy and funds into the water, for sure, on the water today. With the hope that my presentation has steered with you some interest, I thank you for your kind attention. Thank you.
Okay, so thank you, Mr. Luigi. So please stay on the stage. Yeah, and have a seat. So now is the panel discussion for the session 3, floating solutions. I would like to invite Mr. Rasim He will be moderate the panel discussion. Please welcome Mr. Rasim. Thank you. And I would like to invite on stage our speaker to join our panel discussion, Dr. Paul Ong. Paul? Yeah, and together with Mr. Luigi. Thank you so much.
Okay, thank you for your presentation. It was very interesting. We share this. So we have a number of questions, and I will try to announce it one by one. So some of the questions, just want to say that some of the questions you ask here has been already answered. So I take a liberty to skip it, but don't repeat it. So, Mr. Rasim, have the project considered the repurposing of existing facility prototypes? Okay, good question, but it needs to be clarified. What prototypes should be considered? I see the feasibility to use a semi-submersible drilling rigs. If we remove all drilling part and build up on top the farms, it's quite feasible, and then we can use the rest. Jackups also can be used, but ships of vessels, probably not. It's a bit too complicated. Okay. Luigi, what kind of mooring arrangement do these HBS decks have?
Yeah, sorry, can you hear me? Yeah. So the arrangement for the mooring or more berthing, I would say, to be more correct, is a standard marina berthing. So a floating structure, a floating berth, where the boats will then connect in any kind of shape. So the berthing will shape in a way to allow then the boats to have the shape that the customers desire. So in case it is an hotel, for example, because this structure is completely made of glass, we want to preserve a bit of privacy, so they will have quite a wide angle and they won't be dense as the boats are normally dense on a marina. So mainly it depends on the use that you want to do, but these are all structures that they will be berthing marina-like. So on a berthing structure that will help also with the rising sea levels and all that. So they will compensate for that and will be resilient enough to be even moved from there if required. Yeah, they will be dismantled, let's say.
Thank you very much. Another question, it's to me. As a floating farms is on seaways, is there freshwater production on board or rainwater would be sufficient? No, rainwater would not be sufficient, that's definitely. And we have considered, actually it was described in details in the article, just don't have a time here to deliver this message, but freshwater supply was considered few options. First, it's a shore supply, just to buy it from shore. Second is water generation on board. Shore supply, we have found that it's quite expensive, but it could be accepted because the cost of water generation on board is cost of equipment is quite high. So it requires initial investment. On the other hand, water generation on board provides a lot of additional benefits, which we just discussed. It's not only generate the fresh water, it also allows to clean the disposed water. So we have considered several options of water generation, fresh water generation on board. It's a desalination, it's remote osmosis, and the newly developed, it's electrical dialysis. So we believe that osmosis and even dialysis will be the best option to have it on board. And this way, we can provide sufficient and relatively cheap fresh water on board. Rainwater can condensate all this water which we discussed before, it will be complement to it. It's reduce the demand, but cannot satisfy the needs by itself. Okay. Dr. Polom, could we say that some possible directions in terms of approval, there could either be partnership between agencies or even new niche agency?
Good question. I think at the moment there is no new agency for governing floating structures in Singapore. I think you still have to go through BCA and MPA as the first call. BCA has informed us sometimes they allow special cases, special structures where they will rubber stamp approve it as long as somebody has reviewed and approved it. So in a way, if you get a marine warranty surveyor, to independent checker to review and approve the design, they can rubber stamp it. But the agency is not going to change overnight because they're all governed by statutes and they have certain boundaries of what they can and cannot do. So you still have to go through the various departments, authorities for utilities, environmental, fire safety. It will not be a one-stop shop arrangement. It will never. I don't see that coming in the next 5 years. Right? Unfortunately, you just have to live the way the government is organized. Yeah.
Thank you. I would like to add. Sure.
Yes.
I would like to add one point to this moment. I have spoken with a few classification societies representatives, and I have seen they are really keen to develop something, or fully developed, well developed from the classification society. It could be add some weight on the floating structures, and maybe it can initiate some movement from the government to take it as a floating structures rather than.
I think if you follow the route of floating structures, there's no issue at all, right? It's as a vessel. They say follow the classification societies, nothing to do with us, right? Unless you want to build a jetty reaching out to that structure, then the jetty belongs to BCA control, right? Beyond that, it's a floating vessel. Where you want to toll it, where in a position, where do you want to moor it, please consult MPA. There's nothing to do with us. So if you go down that route, then the owner of that vessel will have to deal with the classification society for as long as they own the vessel, which just treat as a vessel, right? The difficult part is where you have a design that is concrete housing, which is neither a vessel nor a building structure, but floating. That's where the gray area comes in.
Yeah, of course, it needs to be resolved. Thank you very much. Okay, next question. I think it's to me. What are the key design considerations for damage stability and against collision, highly likely due to the high traffic density in Singapore waters? That's a good question. It's really dangerous because traffic exist. The first, which I can see here, it's avoiding the situation when could be collided. This way, the area when it will be installed should be stay away from the road. On the other hand, I would like to say that our project was very preliminary. We did not go into the structural design. So the damage stability design and the structural damage design was out of scope. But I believe that it's definitely need to be addressed. And the way to address it, we have it very established for offshore drilling platforms. They have a very well developed damage stability and structural damage rules and regulations which we have to follow. So if it's come to this stage, I believe we can address it properly. Okay. Luigi, dear Luigi, how will the HBS solution change the maritime business ecosystem or challenge the existing solution, accommodation vessel, etc.?
The idea of the flexibility of this kind of structures. So modularity is not only the modularity of the vessel itself, but is the modularity of any structure that can be placed on water. So scalability in a way is an advantage, but also downsizing is an advantage. So this kind of flexibilities will enable to create structures where you're not investing on uncertainty. If the uncertainty is there, if the change is there, the structure will change as well. These structures are going to be producing biodegradable wastes. They're going to be mainly solar. So we are going into this direction so that what we have at hand is something that not only has no toll on the environment, but eventually even helps to purify the water, for example, or to work on solar for that matter. So we are trying not to place any toll on the environment at all. I hope I answered the question.
Thank you very much. Thank you. Next question to the poll. How is APC going to perform over the time due to fatigue from hydrodynamic forces or maybe collision?
A good question. The structure of the concrete EPS system, there's a perimeter concrete around it, just for small impact of ship loads, small vessels. It is not designed for big ship impact. It will not survive that kind of force. So the application is slightly limited to more freshwater, in my views, reservoir near shore, but you're not going to get big vessels coming in. In fact, if you have a big vessel, any collision, even with your structure, it will be damaged, but it's not designed for that. So we will not even go there. The EPS is fully submerged, so it is not exposed to any sunlight. So everything is covered. Is like an inverted shoebox with concrete over it. So it's completely covered. The only exposure is actually to the seawater EPS. So far, my understanding in Holland, they have no issues with the EPS exposed to seawater on the underside.
Thank you. Thank you. Question to Luigi. Has this solution received any class approval?
Yes, this in Italy, it has been manufactured as a class Delta catamaran for a wave, so a vessel, eventually a vessel, for a wave of 0.5 meter. That's the certification. That makes it perfect for inland waterways navigation, of course. It has the facility to add an engine if you require, and it has full controls and lighting. So it is at all, in all ways, it is in fact a vessel. And this has been the classification under which it has been certified in Italy. The same kind of classification is what we are aiming at here in Southeast Asia, because it makes perfect sense to have a vessel that is in fact a hybrid. So it is a house, but in fact it's classified as a vessel. We are hoping that this somehow will facilitate the process of introducing this kind of object in Southeast Asia, given the stringent rules that we are talking about regarding pontoons and structure on the water. So the idea is to make it a vessel and allow it to stay on water thanks to that classification.
Thank you. Next question, I believe it's to me. What is the potential for scaling this farm concept? Would it be feasible to have a multiple unit connected to each other? First of all, I believe that our idea is to scaling up, especially to grow up. The idea to build up a many multi-store farm is saving of the sea space as well. And the more it will be built up to the reasonable limits, the better it will be in terms of the ecosystem or place location finding, in terms of productivity. So it is beneficial to scale it up. Connection of several platforms together, it's need to be considered. If it will be developed as a single complex of food production, and it will be designed in connection with each other, then it will be beneficial for sure. because integration and communication between two or three such farms, shared management, shared marketing, shared logistics, it's all beneficial. If it will be speculative buildings, just connection of the 2 or 3 such farms will make it easier to build a floating road, but probably nothing more. It depends on situation, I believe. I hope I answered this question. Okay, question to Luigi. What is a significant wave height used for the structural design of the floating structure? Response difference between lake and open waters.
Yes, whoever did the question nails exactly the point at the moment. As I said, the classification is for a class delta catamaran. So the wave, maximum wave is 0.5 meter, 50 centimeters at the moment. However, because of my pressure, because I'm in Southeast Asia and we want this to be developed also to be capable, for example, to cross the channel between Malaysia and Singapore, or to be able to also navigate, because that's the requirement we got from some customers towards the island, Riau Islands and all the archipelago, they are redesigning as a category Charlie catamaran that entitles to 2 meters waves and a structure that is way more stable that way for navigation. So that will start to sort out this problem. So at the moment, as it is, I would say is more for inland waterways. The development of the design will modify with that, actually, will progress with that.
Thank you very much. So, this question to me. What is the cost of the bare structure for 6-story structures, which is considered without production assets? What is the expected lifespan of this structure? The cost of the floater we have on the screen, it's about 31 million. Of course, it's estimation based on prototype, not on actual design work. We just scale and transport the basic data from prototype to our dimensions and our rates. I believe that it's close to realistic figures from my own experience, but of course it depends on how it will be built. We have considered steel construction. It is not our goal to design a real structure which stay real time at that moment. Our goal was just to demonstrate that this multiple story with integration will be feasible and beneficial. For that purpose, lifespan of this structure would take as similar to the lifespan of the vessel, which takes about 20 years. Definitely, it could stay more with the maintenance, but maintenance is an additional investment, and we didn't consider it when we calculate depreciation. At the same time, we have considered, but not use it at that moment, building of bottom of floater, underwater floater part from concrete. Floating structure, concrete floating structure. This concrete structure can stay for 100 years if it's built properly. And then lifespan was expanded significantly. Then lifespan of the structure will be defined not life of structure, but rather life of equipment. When the equipment fails, then we need to renew it. And how will stay most probably. So I believe it could be managed for any future projects. How do we take care of the waste management, especially sewage, on this type of major floating structure projects? I'm not sure it's a question to whom. Everybody. Probably, Paul, you want to?
If it's a major structure, of course, probably is not my structure. But anyway, in these kind of structures, which are eventually microstructures, at least initially, as I said, the waste will be managed, liquid waste, in terms of gray and black water that are produced on board. They are initially stored, and then they can eliminate it either through a water treatment system so that they can be released in the water. For example, if the location is not a marina. In a marina, you can have always a pump up facility so that they come and empty your tanks. But if, for example, this is developed in a remote island where you want fast deployment of a structure for a particular project or an urgency, then if you have this kind of water treatment, solar paneling and all that, that will have no impact on the environment, that can be easily produced without any other infrastructure apart from a bird.
For me, it's the same questions about electric car. It's about infrastructure. Right? You can design lots of electric cars. You don't have infrastructure to charge your electric car. Pointless. Right? Nobody's going to buy it. Maybe people buy it just because you just have enough electric charges. If everyone buy electric car today, they will all be queuing for electric chargers, right? You will just be stuck at home, not having the electricity. So the same thing with all this infrastructure. You have to look at the infrastructure on land to support living on water, deal with the waste, and Singaporeans are very lazy. They need to be near MRT as well. Yeah. So you cannot have that house in Marina, Raffles Marina in Tuas. And then if there's no MRT, then it says, why do I live on this bottom? I just live in HDB flat, right? So it's a whole infrastructure that you need to support living on water and working on water. That's the Singapore context, unfortunately. Yeah.
Since you mentioned that, I just want to add something. Now, the issue of these systems, this infrastructure that needs to be created, for example, for transportation, is something that really bugged me when I was living in Sri Lanka before coming to Southeast Asia on this side. And the fact of using water for transportation and have an infrastructure which is modular and movable, that will give the possibility always of creating a system that can be modular and moved. The cost will be inexpensive, I would say, compared to land reclamation and doing something like that on land. You can do that on water with a simple berthing. So that would sort out the problem that way, probably. I don't know. I'm just guessing.
Thank you very much. I believe our time is out. So thank you everybody for your question. Thank you for people for your answers. It's a pleasure to talk with everybody. So this is the end of our Q&A session.